Now we are turning our attention to solving rational equations, and let me make a point here. You are going to be multiplying through by the least common denominator on each side of the equation. This is what you need to do to solve these rational equations. Please read my comment here. But do not apply this process on the regular addition and subtraction problems that you find in the first half of the chapter. We are allowed to multiply through by a least common denominator on each side of the equation because we're doing it to both sides of an equation. In this first problem, we see that the least common denominator is 8x, and what you can do is say I'll multiply on each side by 8x as I've drawn here, although most people, because there's going to be distribution and they like something to cancel with, tend to write in 8x in each of these positions. Now I can cancel the 8's, cancel the x's, cancel the x's, and what I'm left with is going to be 32 is equal to 24 plus x, and then subtracting the 24 off of each side, we have x is equal to 8. Now, with these types of equations, it is necessary to check our answer, and especially make sure that when you substitute this into the problem where the x's are, you do not get a 0 in the denominator. And it turns out that 4/8 is equal to 3/8 plus 1/8, so we have no problems here. In this next problem, the least common multiple that we want to multiply through by is 12x. So when we multiply through by 12x on each side, in the first fraction, the 12's will cancel, leaving x times the x that's already there, so we have x squared. In the second fraction, not only does the x cancel, but 3 cancels with the 12, giving you 4 times the x plus 3 that's already there. On the right side of the equation, the x's cancel, and you have 1 times 12, which is equal to 12. Distributing, you now have x squared plus 4x plus 12 is equal to 12, and you will note that we can subtract 12 off of each side easily. Factoring the left, we have x times x plus 4 is equal to the 0 that's on the right, and we have solutions of 0 and negative 4. So it appears. But when you go and check these solutions, you'll note that 0 does not check because it creates a 0 in the denominator of the original problem. 0 is known as an extraneous solution. I like to consider them to be like weeds. They're things that just kind of pop up out of nowhere that you have to check for, and it's very important to do that when solving these rational equations. It turns out that negative 4 is the only solution to this problem. For problem number 3, before we can multiply through by the least common denominator, we need to factor this first denominator, and we can see that 4 times n minus 1 will be the least common denominator that we're going to multiply through by on each side, even though I've only written it there on the right side. On the left, all of that cancels, leaving just 2 minus 7 times. After the 4 cancels, you have n minus 1 equals negative 3 times, after the n minus 1's cancel, times 4. So that becomes negative 12. On the left, we distribute. We get 2 minus 7n plus 7 is equal to negative 12. We can then combine like terms on the left, and that gives us negative 7n plus 9 is equal to negative 12. Subtracting 9 on each side, we have negative 7n equals negative 21, and therefore n is equal to 3. A quick check shows us that this is not a bad value or an extraneous value. 1 would have been an extraneous value to cross off because 1 minus 1 makes 0 in the denominator, but 3 is most likely going to be a valid solution. In this next problem, we note that the third denominator on the right-hand side factors into the difference of 2 squares, and that this difference of 2 squares is the least common denominator that we're going to multiply through by on both sides so that we can cancel out these denominators and continue on our way. So on the far left, we've already got a 4x in the numerator, and after the x plus 3's cancel, we will have a factor of x minus 3 multiplied into our equation. The middle fraction has a 12 up in the numerator, and after the x minus 3's cancel, it will be multiplied by x plus 3. Finally, on the right-hand side, the whole x plus 3, x minus 3 cancels, leaving the 4x squared plus 36 that we see there. Now on the left side, we're going to do some distribution. We get 4x squared minus 12x, then again minus 12x minus 36 equals 4x squared plus 36. Now it's time to do some cleanup. We notice we can subtract 4x squared on each side. We also notice that we can combine like terms on the left side. This leaves us with negative 24x minus 36 is equal to 36. Adding 36 to each side, we get negative 24x is equal to 72. And dividing through by negative 24, we now have x is equal to negative 3 as a potential solution. But when we check it back in our original problem, we notice that we have a problem. Actually, I should have drawn my arrow right here. Negative 3 plus 3 is 0 in the denominator, and that will not work. So our solution here is that there is no solution. This is a no solution problem, which happens every once in a while when you're dealing with these rational equations, especially when you've got to check for extraneous solutions. Let's talk about this next problem. If you were to multiply through by x minus 1, which is the least common denominator, on the left, the x minus 1 would cancel, leaving x squared plus 3x. And on the right, the x minus 1 would cancel, leaving 4. This would give us a quadratic equation, x squared plus 3x minus 4 is equal to 0, which we would then factor into x plus 4 times x minus 1. And note that our potential solutions are negative 4 and positive 1. But that the 1 does not check when you go back to the original problem because it is extraneous. Therefore, negative 4 is our only solution. But let's look at this problem a slightly different way. When you have a proportion, fraction equals fraction, you are used to cross-multiplying. So let's take a look at this problem if we were to have cross-multiplied instead of multiplying through by the least common denominator. We would have had on the top left x squared plus 3x multiplied by the x minus 1 in the bottom right corner equals the product of the other diagonal, 4 times x minus 1. On the left side, we would be FOILing, getting x to the third minus x squared plus 3x squared minus 3x equaling the 4x minus 4. And then we would be cleaning this up, setting it equal to 0, subtracting the 4x off and adding 4 to both sides, and that would give us x to the third. We do have a minus 1 plus 3, so a plus 2x squared. Subtracting 4x off of each side gives us minus 7x, and then plus 4 is equal to 0. At this point, we get to a third degree equation that we don't know how to factor. Now, we know the answer will be negative 4 from how we solved it the first time, but we're not going to learn how to solve this type of equation until we get to college algebra. So here we kind of draw a blank, and we're kind of stuck with the skills that we have now. So even though cross multiplication is a process that would eventually work, we will find that multiplying through by the least common denominator is actually a better process because it clears the denominators and gives us equations of lower degree instead of having to deal in this problem with this x to the third. So hopefully that's another pointer I can give to you. Let's solve this rational equation by multiplying through by the least common denominator, which is 6y. On the left, 2y cancels with 6y, leaving 3, which we then multiply by the y plus 1 that's up there in the top left already. On the right, the 3 cancels with the 6, leaving 2y times 2, making 4y. Distributing on the left, we have 3y plus 3 is equal to 4y, and subtracting the 3y off of each side gives us y equals 3. We take a quick look and verify that 3 will not substitute back in and give us a 0 in the denominator. And for the moment, that looks like it's going to be the solution that works.